Welcome back, everybody. It's awesome to have you here with us for another deep dive. Today, we're back with more fascinating perspectives from Dr. Alok Aggarwal's book, The Fourth Industrial Revolution and 100 Years of AI.
Last time we were talking about how AI is revolutionizing things. Everything from discovering new materials to totally changing how drugs are developed. And we were pretty much blown away by just how much potential AI has.
I know, right?
But we also talked about some areas where AI is still kind of struggling, like in precision medicine.
Yeah, there are definitely still some challenges there.
Today we're diving into some mind-bending predictions about AI's future, while exploring a fascinating paradox: how the same challenges that puzzled AI researchers in the 1970s continue to perplex us today. We'll also uncover some surprising ways deep learning networks can be tricked, leading to what experts call machine hallucinations.
That's really interesting.
So let's start with the big picture. Is AI really this limitless force that everybody's talking about? Or are we all just caught up in another wave of hype?
That's a great question. One of the first things the book points out is that all this excitement about AI right now, it's actually a lot like what was happening back in the 1960s.
Oh, really?
Yeah, back then, everybody had these super high expectations for AI, but the technology just wasn't ready yet. It couldn't do what people were hoping for.
Oh, wow. So it's like a good reminder that we need to be a little cautious, even though it feels like we're on the edge of something huge with AI.
Absolutely. And keep in mind, there are some seriously smart people making some pretty wild predictions about what's next.
I've heard about some of those predictions, like Ray Kurzweil. He says AI will be as smart as humans by 2029. And then by 2045, it'll be way smarter than us.
That's right. And Gray Scott, he goes even further.
Oh, really?
He thinks human brains won't be able to keep up with AI by 2035.
Wow. Those are some pretty mind-blowing predictions. Maybe even a little scary.
I know, right?
But it's not all doom and gloom, right?
Oh, definitely not.
There are people who think AI could actually solve a lot of the world's problems.
Exactly. Yeah. People like Stuart Russell and Oren Etzioni, they think AI could be the answer to things like climate change, poverty, really big problems.
That's amazing.
Yeah. So it's a pretty wide range of opinions, to say the least.
It is a lot of different viewpoints. So how do we even start to make sense of all of them?
Well, one thing the author talks about is how we see AI as this kind of magic.
Magic?
Yeah, and that really shapes our predictions about it. It reminds me of that famous Arthur C. Clarke quote.
Oh, the one about advanced technology.
Exactly. Any sufficiently advanced technology is indistinguishable from magic.
I love that quote.
Me too.
So it's because we don't totally get how AI works, it just seems like this mysterious force.
That's exactly it. And that's what fuels both our utopian dreams about AI fixing everything and our fears about it going out of control and becoming a threat.
Right?
So it's this duality that the book really explores.
So we've got this idea of AI as magic.
Right?
Which makes it hard to tell what's realistic and what's just fantasy.
Yeah.
But let's talk about those fears for a minute. People like Elon Musk, they've said some pretty serious stuff about the dangers of AI.
That's true. Yeah, he's been very vocal about his concerns that AI could actually be an existential threat to humanity.
And Stephen Hawking too, right?
Yes, he also talked about the possibility of an intelligence explosion.
I've heard about that. It's the idea that AI could get so much smarter than us, so fast.
Exactly.
Way more than the difference between us and insects or something.
Right, that was Hawkins' analogy, like humans compared to snails. That's how much smarter AI could potentially become.
Wow. And Nick Bostrom, he even said AI could be more dangerous than nuclear weapons.
That's right. He argues that AI could even lead to human extinction.
Those are some seriously heavy predictions.
They are.
Are they really justified?
It's the big question, isn't it? We can't just ignore the possibility of an intelligence explosion. It's there.
Right?
But we also need to think critically about how likely it is and when it might actually happen. We need to be realistic, acknowledge the risks, but not just give in to fear-mongering.
This all feels like something out of science fiction.
It does, doesn't it?
It makes me think of Isaac Asimov's Handbook of Robotics.
Yeah. And his 3 laws of robotics.
Yeah. Or HAL 9000 from 2001: A Space Odyssey.
Oh yeah. That was based on Arthur C. Clarke's short story, The Sentinel. These themes have been around in science fiction for a long time. It shows our deep anxieties about technology getting out of control.
And now those sci-fi ideas are starting to feel more real.
Exactly. It's really interesting to see how it's playing out.
Remember that time back in March 2023 when a bunch of big tech people called for a pause on AI research?
Oh yeah, that was big news. They did.
Yeah, people like Elon Musk and Steve Wozniak signed that open letter, right?
It shows how worried some people are about the potential consequences of AI.
So is that like a real turning point or just a bump in the road to this superintelligence?
Yeah, that's the question.
It's clear that AI is bringing up some really profound questions about our future.
It is.
And there's no easy answers.
Yeah, it really feels like we're at a crossroads with all of this.
It does. And it's kind of like, how do we even deal with all of this? We can't just stop all AI research forever, can we?
No, that's not really an option.
So what do we do?
Well, this is where Dr. Aggarwal's ideas in the book get really important. He's saying, yeah, all the hype and excitement about AI is cool, but we also need to be realistic about what AI can't do yet.
Okay.
Well, some of the same problems that AI had back in the 1970s, they're still around today.
Really? But I thought AI has gotten so much better since then.
Oh yeah, the computing power is way better now. And we have like tons of data to feed these AI systems, but some things are still super hard for AI.
Like what?
For example, AI struggles with something called transfer learning. You know, it's like imagine a little kid who knows what a cat looks like, right? You show them a picture of a civet.
Okay.
They'll probably be like, oh, that looks like a cat.
Right.
You know, they just make that connection.
Intuitively.
Yeah, but an AI needs to be completely retrained to recognize a civet as a totally different animal.
So no shortcuts. Every variation is like starting from scratch.
Pretty much.
That's got to be a major roadblock, especially for things like image recognition.
Oh, absolutely. That's one of the big reasons why AI development is so complex.
I can imagine.
We're basically trying to copy something that we don't fully get ourselves, the human brain.
Yeah, billions of neurons making connections we can't even map. So how do we build an AI that thinks like us when we don't even know all the rules?
That is the question. A question people have been debating for decades. Back in the 80s, this philosopher, Hubert Dreyfus, pointed out some fundamental differences between human and machine thinking.
Okay.
One key difference is that AI relies on formal rules and logic, while we humans are much better at understanding context and nuance.
So AI needs like step-by-step instructions for everything, whereas we can just kind of roll with it.
We can adapt to the situation, something AI really struggles with.
It's like AI is all about following the recipe exactly. And humans are like, okay, a pinch of this, a dash of that, we'll see what happens.
Exactly. And Dreyfus also argued that a lot of human knowledge is what he called tacit.
Tacit.
Yeah, meaning it's hard to put into words or write down as a rule. Think about riding a bike. You can describe the mechanics.
Sure.
But you really gotta learn by doing, and you can't program that.
Not really.
And that leads to another interesting thing.
Okay.
The meaning of a symbol can completely change depending on the situation. AI has a hard time with this because it processes info in a very literal way.
So context is key for us.
Right?
And AI is still playing catch-up.
Yeah, it reminds me of Moravac's paradox.
Oh yeah, AI can beat chess grandmasters but can't pick up a toy like a toddler.
Exactly.
Makes you wonder, if things we find difficult are easy for AI and things we find easy are hard for them, what does that even say about intelligence?
That's a great question. And it suggests that maybe we underestimate those simple tasks.
I guess so.
Moravac thought it was because our senses and motor skills have been evolving for billions of years.
So we take them for granted. Walking, recognizing faces, it's all super sophisticated.
And AI is still struggling to get there.
And this kind of ties into another limitation, the black box problem.
Oh yeah, we've built these complex systems that do incredible things, but we often don't really know why they give us the answers they do.
Like a magic 8-ball.
Exactly.
Sometimes it's eerily right, but no clue how it works.
Right? And that can be a bit unsettling.
Especially with things like AI and healthcare.
Oh, for sure. There's a famous example. Deep Patient, developed at Mount Sinai Hospital, turned out to be amazingly good at predicting schizophrenia.
Really?
Even better than experienced psychiatrists.
Wait, we have an AI that could save lives.
Yeah.
But we don't know how it works? That's kind of scary.
And this lack of transparency makes it hard to trust AI.
Especially when the stakes are high.
Absolutely. And then there are questions of accountability.
Like, who's to blame if it makes a mistake? That's a whole other conversation we need to have.
Definitely.
But before we get there, I'm curious about the practical side. Building and training these systems has got to be expensive.
Oh, it is expensive. You're right about that.
Give me some numbers.
Okay, so training AlphaGo, the one that beat the Go champion, that cost $35 million.
Wow.
And that was just the training.
So it's not even just building it, it's like you gotta keep feeding it.
You could say that.
And we were talking about all that data it needs.
Yeah.
What makes that so tough?
Well, think of it like baking a cake, right? You need good ingredients.
Yeah.
Most of the data online is like using expired flour and stale eggs.
So garbage in, garbage out.
Exactly. And even if you find good data, then you have issues of ownership and copyright.
Like who has the right to use it?
Exactly. And what happens if it's used without permission?
Those are some big questions. Seems like we're just scratching the surface of how AI is going to change things.
Think so.
What else should we be thinking about as we head into this AI-driven future?
Well, one of the most important things is to be aware of potential biases.
Okay.
Remember, AI learns from the data it's given, right? So if that data reflects existing societal biases, let's say gender or racial bias, the AI could make those biases even worse.
So it's not just about building a smart system.
No.
It's about making sure it's not amplifying harmful stereotypes.
Exactly. It's a huge responsibility.
It really is.
Which is why diversity in AI development is crucial.
Makes sense.
We need people from all backgrounds to help identify and fix those biases.
Absolutely. Now we're going to find out why even cutting-edge AI can confidently give you totally bogus answers. And then we're going to talk about what's being done to try and fix it.
Okay, so one of the biggest hurdles right now is this idea of brittleness.
Brittleness?
So think of it this way. You're cruising along in your self-driving car, and suddenly it slams on the brakes because a tiny speck of dust landed on the camera lens. That's kind of what brittleness means for DLNs. A small change in the data can throw them completely off course.
That's not exactly filling me with a lot of confidence about handing over the wheel to AI anytime soon.
No.
But I guess that's why they call it deep learning. I mean, it's still learning.
Exactly. And it's a big deal, especially when you think about AI making decisions in self-driving cars, medical diagnoses, things like that. Accuracy is key in those situations.
Yeah, the book mentions researchers fooling these supposedly super smart AI systems with these tweaked images that were basically meaningless.
Right.
But the AI confidently mislabeled them as penguin and starfish. You know, all this crazy stuff. It's almost funny, but it's also kind of scary to see how easily these systems can be tricked.
It all comes down to how they learn.
Yeah.
They're trained on these mountains of data, but they don't truly understand it the way that we do. They're masters of pattern recognition. But when it comes to reasoning or context, they can fall short.
Oh, and that brings us to machine hallucinations, where AI confidently gives you an answer that is just plain wrong, like it's making things up on the spot.
Right? The book gives this great example with MIT's iconic domed roof.
Okay.
So they asked GPT-3, this powerful language model, what was distinctive about MIT's roof.
Let me guess. It came up with something totally wild.
Yeah. Instead of saying like, I don't know, or trying to look it up, it confidently claimed that the roof was made of grass or had red clay tiles.
Wow.
It's hilarious and unsettling that it would just invent an answer instead of admitting that it didn't know.
So even though they can churn out text or even create these amazing images, they're not actually thinking behind the scenes. It's just sophisticated pattern matching.
Exactly. They lack that common sense and contextual awareness that we humans take for granted.
Right? Makes you wonder what other hallucinations are these AI systems having, and how can we even tell what's real or what's just a figment of their digital imagination?
Right? Well, the book gives a few more examples, actually.
Okay.
There's Google's Imagen, which struggled to accurately describe even a simple arrangement of blocks. And then there's ChatGPT, another language model that wrongly insisted that CPUs were faster than GPUs for deep learning, which just isn't true. Even Andrew Ng, a leading AI expert, has shared stories on LinkedIn about ChatGPT giving him completely wrong answers.
Wow.
So it's definitely out there.
Okay. I mean, is there anything being done to address these creative liberties that AI seems to be taking?
Researchers are definitely working on it. There are two main approaches that are being explored right now.
Okay, lay them on me. I'm ready for some good news.
Okay, so the first approach is called the ensemble approach, which is like having a team of AI experts instead of just one.
Okay.
By combining multiple DLNs, they hope to increase accuracy and reduce individual biases or errors. So think of it as a checks and balances system for AI.
Strength in numbers.
Exactly.
What about the second approach?
Okay, that involves combining those powerful transformers, like GPT, with internet search engines. This basically allows the AI to fact-check its short answers by comparing them to external information.
So like giving the AI a research assistant?
Exactly.
To double-check its work? So does that mean we're on the road to fixing these issues?
It's a good start, but it's not a foolproof solution. While it helps with short, factual answers, it's not so effective for longer, more complex responses, where reasoning and context are key.
Right.
We still have a long way to go before we can fully trust AI systems to always be accurate and reliable.
Well, I, for one, am glad that these brilliant minds are working on this. But this brings up another point that the book mentioned. Ted Chiang's article, ChatGPT is a blurry JPEG of the web, and his insights on how these DLNs store information.
Yeah, Chiang suggests that DLNs might be storing information in a highly compressed form, kind of like a blurry JPEG image.
Okay.
And when the AI tries to reconstruct that information, it can lead to those fabrications and hallucinations that we were talking about.
So it's like trying to make out the details in a blurry picture. You might think you see something, but it's not really there.
Exactly. That compression could be a fundamental limit to how much information these systems can handle without introducing errors.
Okay.
Chiang also points out that DLNs do really well when they have tons of data to work with, like when discussing economics, for example. But they struggle with less common scenarios where their training data is limited, like adding really large numbers.
So it's not just about how much data they have, it's also the quality and the variety of that data.
Absolutely. Garbage in, garbage out applies to AI just as much as anything else. If you train an AI on biased or incomplete data, its output will reflect those limitations.
And to add another layer of complexity, the book talks about these imitation GPTs, which are essentially AI models that are trained on the output of other AI models.
Right? Sounds like a digital echo chamber.
Yeah. And the results are a bit concerning. Studies by Gouda Bande and Shumailov show that these imitation GPTs really struggled with accuracy and can't reliably reproduce factual information. It's like making a copy of a copy. The quality degrades with each generation and really highlights the importance of using high-quality, human-verified data for AI training whenever possible.
Couldn't have said it better myself.
Well, it's clear we've got a lot to unpack here. This deep dive into the limitations of DLNs has been fascinating, but also a little unsettling. We've explored the full spectrum of AI predictions, from the dreamers to the skeptics, and uncovered why some challenges from decades ago still haunt us. We've delved into the fascinating world of machine hallucinations, discovered why AI can be surprisingly fragile, and seen how crucial training data really is. Plus, we've explored some promising solutions that researchers are developing to tackle these challenges.
Yeah, and we've only just scratched the surface. Well, in our next deep dive, we'll be exploring even more limitations of those powerful transformers and large language models. We'll be talking about concepts like machine endearment and malware injections, and examine the significant consequences that these limitations could have.
Those terms sound both intriguing and a little bit terrifying. I can't wait to delve into those topics.
Until then, keep those thinking caps on, and we'll see you back here for another deep dive into the world of artificial intelligence.
All right, thanks everyone.
See ya.
We'll see you next time. Bye.